Good evening, sir.
Hmm. See, today I start Basel's equation or Basel function. तो जैसे legendary equation and legendary polynomial, similarly Basel equation and Basel function. So Basel equation, it is a particular type of second order ODE. You can see the form x square y double dash plus x y dash plus x square minus nu square y is equal to 0. So that is the form of Basel's equation, where nu it is a positive real number or 0. Okay, nu is a positive real number or 0. Actually, if it is asked to solve this problem, it is a problem of Frobenius method, is not it? Because you can see x is equal to 0 is a regular singular point here. So you have to solve it, you have to apply Frobenius method. So maybe in the previous chapter there are some question. No, not exactly that Basel equation is given. Whatever means you can solve this Basel equation by Frobenius method. Same technique. You will get the roots, means roots of the initial equation. Just a minute.
Hello, hello.
Yes,
Nothing, sir.
I was in a call actually. That is why I muted. Okay, so I was telling that you can solve that Basel equation by Frobenius method, where x is equal to 0 is a regular singular point. So you have to take this type of power series solution, right? In Frobenius, this type of power series solution we have taken m0 to infinity a m x to the power n plus r, provided a not equals to 0. So I'm giving you this as homework. Uh, how to get the solution of this? Okay, at least how to get one solution, means y1x. It will be in terms of new, but you can find it by Frobenius method. So I'm giving you this as homework. Uh, Actually, today I want to discuss some special function which is used in Basel equation and Basel function. So, firstly, I will discuss this special functions. Then, again, I will discuss the solution of the Basel equation and Basel functions. Okay. So, do you heard about beta function and gamma function? Have you heard about that? Beta function, gamma function? Tell me.
No, sir.
Mostly, there are some use of beta and gamma functions in JEE main or advanced topic. Maybe. Uh, so no problem. See, why we are discussing this? Why I am discussing this special functions? Because there have some use of this special function in Basel equation. Okay. So we will discuss beta function and gamma function. These two type of special function. So what is gamma function? See, gamma bracket alpha. So notation for gamma, normally we denote fx as function of x. Okay. But we are denoting gamma, since it is a special function, we are giving a special symbol to it. It is denoted as this. It is like a vertically flipped L. Okay. Gamma bracket alpha means it is a function of alpha. So how it is defined? The function gamma alpha, it is defined by the integral 0 to infinity e to the power minus t to the power alpha minus 1 dt. So you have to remember this form, this integral form. Gamma alpha, it will be 0 integration 0 to infinity e to the power minus t to the power alpha minus 1 dt. Okay. Look, in some book it is given in that form also. Gamma m 0 to infinity e to the power minus x to the power m minus 1 dx. Same thing. So here the function gamma function, it is basically an integral, rather an improper integral. So Integration 0 to infinity e to the power minus t to the power alpha minus 1. See where that use, what is the use of that alpha? Here it is in the power of t to the power alpha minus 1. Now you think if you solve an integration with respect to t, okay, where alpha is included, so after solving that integration it will be function of alpha or not? You are integrating, means you are solving a definite integration, right? Where, means with respect to what? With respect to t, and where alpha is included. Alpha is a parameter, you can consider it as constant. Okay, so ultimately the value of the integration, it will be a function of alpha. Do you agree?
Yes, sir.
Yes, sir.
Yes, sir.
That is why it is written gamma of alpha, not gamma of t. Okay, it is not a function of t, it will be a function of alpha. So here the condition is, there are some condition on alpha, that alpha should be greater than 0. In that formula, alpha should be greater than 0. In fact, actually in generalized form, real alpha greater than 0 means alpha may be complex, but that is the generalized case, and I will not discuss about that. Only we will discuss for real value whenever alpha is real, positive real. So in our case, we are assuming only alpha greater than 0. You can ignore this. Now there are some property of this gamma function which you need to know. The first property, it is gamma alpha plus 1. Gamma alpha plus 1, it is alpha gamma alpha. Okay, gamma alpha plus 1 will be alpha gamma alpha. There I have some proof. It is a simple proof. You can prove it easily by that integral. Actually, what is gamma alpha plus 1? According to the definition of gamma alpha, if you put alpha is equal to alpha plus 1, it will be 0 to infinity e to the power minus t to the power what?
Alpha.
Alpha dt. Now what you will do, you apply integration by parts by taking this as first function. So it will be t to the power alpha integration of this e to the power minus t. Integration will be minus e to the power minus t. That will be the first term, 0 to infinity. And the second term will be integration, differentiation of first term, means ddt of t to the power alpha. It will be alpha t to the power alpha minus 1, and then integration of e to the power minus t. So it will be plus, right? Sorry. Are you getting or not? I have applied integration by parts by taking t to the power alpha as first function. So you will get this. And by putting the limits, you will get this in this term value 0. And it is what? It is nothing but alpha gamma alpha. So that proof is given in the book also. You can see the proof from the book. It is a simple proof. You just do one step by parts, you will get this result. This result is important, proof is not. So the result is, again I am repeating, gamma alpha plus 1, it is alpha gamma alpha. Okay, and that is a basic result. Gamma 1, it is equals to 1. That means if you put alpha is equal to 1, okay, if you put alpha is equal to 1, then the integration value of the integration will be 1. It is also easy to verify. You put alpha is equal to 1 in that integration, then it is simple integration 0 to infinity e to the power minus t dt. And what is the value of this integration? It is 1. You see, integration, what I told, 0 to infinity, I am showing for one reason. This, what is the value of this integration? Can you tell me how this is 1? I told this is 1. So integration, it will be minus e to the power minus t, right? Now put the limit. Now minus e to the power minus infinity minus e to the power 0. Sorry, it will be minus minus plus. Now what is the value of e to the power minus infinity?
0.
0. Actually, it is not exactly e to the power minus infinity. It is improper integral. That is why यहाँ पे you have to think limit t tends to infinity e to the power minus t, and the result is 0. So e to the power minus infinity tends to 0. Therefore, you can put directly e to the power minus infinity is equal to 0. Okay. You should remember this. That is why I have shown e to the power minus infinity, that is 1. Sorry, e to the power minus infinity, that is 0. And e to the power 0, it is 1. So 0 plus 1, 1. Ultimately, we are getting this. So that is a basic result. Gamma 1 is equal to 1. Now, using these two properties, we can derive value, gamma value for the other integer, other positive integer. How? See, gamma 1, 1, right? By this property. Gamma 2. So gamma 2, that you can think as alpha plus 1. So gamma 1 plus 1. Then it will be 1 gamma 1 by this property. Can I write it? Gamma 2 is equal to 1 gamma 1.
Yes, sir.
And gamma 1 is 1. Therefore, gamma 2 is equal to 1. Next, gamma 3. So gamma 3, you write it in that form, gamma alpha plus 1. So alpha will be 2. Right. So gamma 3 is equal to 2 gamma 2. And in the previous step, we got gamma 2 1. So 2 into 1, that means 2. So gamma 3 value 2. Next, gamma 4. Gamma 4, you think it as gamma alpha plus 1. So alpha 3. So it will be 3 gamma 3. Right. And gamma 3 value, it is 2. So 3 into 2, 6. Similarly, you can see that all the values are coming in factorial form. So if it is some positive integer, then gamma of that positive integer is equal to factorial of that integer minus 1. Means in general, I can write gamma of k is equal to k minus 1 factorial. Okay? Can I write this? When k is any natural number. Do you get it or not? Gamma k, it will be k minus 1 factorial. When k is any positive integer. Or we can write gamma k plus 1, it is factorial k. So if k is any integer, then finding the value of gamma, it is easier. It is related to factorial. Okay. Now, if the value is a fraction, in that case, it will not be in terms of factorial. So in that case, calculation will be a bit difficult. Up to that, is it clear that gamma of an integer k is equal to k minus 1 factorial?
Yes, sir.
Yes, sir.
Okay. Now, in the basic definition, I told alpha should be positive. This. But if you apply this property of gamma function and extend it, it can be extended for negative real number also. So what I told, again I am repeating, that usually gamma function is defined for positive real number, but we can extend it for the negative real numbers also by using the property gamma alpha plus 1 is equal to alpha gamma alpha. So how I'm extending the definition for negative, you see. But you remember that if this extension, it is not for all negative real number. Means we cannot extend the formula for this. If alpha is equal to minus 1 or minus 2 or minus 3, means negative integer, negative for negative integer, that extension is not possible. But for any other negative real value, that the extension is possible. So how to extend it, you see. Actually, I am using that same formula, gamma alpha plus 1 is equal to alpha gamma alpha. Okay. So from here, I can write gamma alpha is equal to gamma alpha plus 1 divided by alpha. Right. Can I write this? That is a simple fact. Gamma alpha plus 1 is equal to alpha gamma alpha. Then gamma alpha will be gamma alpha plus 1 divided by alpha. So you see, actually, if it is asked to find the value of gamma, say 3 by 2. Okay, sorry, minus 3 by 2. Gamma minus 3 by 2. Fine. So how to find it? Actually, I will relate that gamma minus 3 by 2 to some positive gamma value. How to relate it? So here you think alpha is minus 3 by 2. Fine. So by this formula, what I can write? Gamma 1 minus 3 by 2. Na? Alpha is minus 3 by 2. So minus 3 by 2 plus 1 means what? Minus of divided by what? Minus 3 by 2. Okay. Now you see still it is in the form of gamma negative. Now again apply that same formula. Now you consider for gamma minus of, you apply this formula. Gamma alpha is equal to gamma alpha plus 1 divided by alpha. So what will be the value? Now alpha is our minus of. It will be gamma minus of plus 1. So it will be gamma plus of, right? Divided by alpha. Alpha means minus 1 by 2. And minus 3 by 2 already there, to minus 3 by 2. So see what I did. I have converted this gamma of some minus real value is equal to gamma of some positive real value with some constant multiply. That is not an issue, but means I can relate that gamma negative value to a gamma positive value. right? By applying this formula. Do you get it?
Yes.
So by repeated application of this formula, gamma alpha is equal to gamma alpha plus 1 divided by alpha, we can find the value of gamma negative. But gamma of means minus 2, you can write gamma of minus 2. It is not possible. You cannot write it in terms of positive gamma. Or gamma minus 1, gamma minus 5. For integer, it is not possible. It's negative integer. Now see, so after repeated application of this formula, we can write this. Means until this value is not positive, we will apply this formula. Okay. So whenever we got that value alpha plus k plus 1 positive, then we stop. So the general formula means after repeated application of this, it will be what? See, okay. Now these are the properties I have written. Now for negative extension, I'm using. So what is this? I'm applying this formula gamma alpha plus 1 is equal to alpha gamma alpha. So from that I can write this. Look, now after applying fast time, okay, means यहाँ पे जैसे हुआ gamma minus 3 by 2, alpha minus 3 by 2. So I have applied this. It is still negative, right? Gamma minus half I am getting. It is still negative. Then again you have to apply that formula again. Gamma alpha equal to gamma alpha plus 1 by alpha. So up to when you have to apply this formula till this value is not positive. This value is positive, right? Until we get gamma positive value, right? So after applying that formula first time, that may be negative. Gamma alpha plus 1 may be negative. So for that, what you will do? Again, I apply the formula. So for that, it will be gamma alpha plus 2 divided by alpha plus 1 into alpha. Can I write this? Means for gamma alpha plus 1, I am applying the formula again. Means main formula is this: gamma alpha is equal to gamma alpha plus 1 divided by alpha. Okay. So for if alpha is equal to alpha plus 1, then it will be gamma alpha plus 2 divided by what? Alpha plus 1. So gamma alpha plus 2 divided by alpha plus 1 and alpha uh, remaining. Now again, if that gamma alpha plus 2, that alpha plus 2 is negative, you have to apply same formula. So again, now put alpha is equal to alpha plus 2. So it will be gamma alpha plus 3 divided by alpha plus 2, and rest of the terms you write alpha plus 1 and alpha. Okay. By using that repeated application of that formula, means after kth term, means after kth application of this formula, it will be gamma alpha plus k plus 1 divided by what? Alpha plus k. Then next term will be alpha plus k minus 1, and as a alpha plus 2, alpha plus 1, alpha. So I am assuming that I got this alpha plus k plus 1 now positive. I can stop here. So in that way, I can find the gamma negative real value. Any doubt?
No, sir.
Look here, k is the smallest integer such that this is positive. Means whenever you are getting this term positive, then only you stop. Otherwise, you have to continue. Now there are some well-known properties of gamma function. These are the basic properties. Gamma alpha plus 1 is equal to alpha gamma 1 is equal to 1, gamma k is equal to k minus 1 factorial. So there are some other properties also. Uh, Gamma half is equal to root pi. It is an important property. Sometimes in exam this problem is given. Okay, you may get this problem as means proof of this property. So gamma half is equal to root pi. Means you should know that the value of gamma half, it is equals to root pi. Means in that formula, if you put alpha is equal to half, the value of this integration will be what? Root pi. That we have to prove. इसका proof आता है exam में. And rest you can ignore because for now there are no detailed part of the beta and gamma function, because actually since there are use of this gamma function in Basel's equation, that is why I'm introducing, but there are no detailed part. Only first property we need proof of it. Now see the proof. Look, in some in the middle, you may ask how this is coming. So better not to ask how this is coming at this time, because means it is not possible to understand this proof at this point. But after uh, means after gaining knowledge of the vector calculus, you have vector calculus, na? In your syllabus, you have vector calculus. So whenever it will be taught, after that you can understand this proof. And at that time, I also discuss this proof also again. Okay. Actually, we need to use the notion of double integration. Have you seen double integration?
Yes, sir.
You know. So if you know, it is good. Otherwise, uh, there are double integration, single integration, triple integration in your syllabus in the portion vector calculus. Okay. See how we are proving this. So gamma alpha, the definition is gamma alpha 0 to infinity e to the power minus t to the power alpha minus 1 dt. Now we need to know the value of gamma half, right? So you put alpha is equal to half in that formula, in the definition. So it will be gamma half is equal to 0 to infinity e to the power minus t to the power half minus 1. So half minus 1 means minus half. So integration 0 to infinity e to the power minus t to the power minus half dt. Okay. Now you can try it, but you cannot solve this integration directly. Okay. There are no method of direct integration, means by any kind of substitution or any other formula. You cannot solve this definite integration. That is why we need this concept. So what I am doing to solve this integration, first of all, I am taking t is equal to u square. Okay. So if I take t is equal to u square, then dt will be 2u du. So substitute now e to the power minus u square and u square to the power minus of. That means u to the power minus 1. And here 2u du. Ultimately, what we are getting? E to the power minus u square to the power minus half into 2u du, right? Limit will be 0 to infinity. It remains unchanged. T0, then u0, t infinity, then u infinity. So limit unchanged, 0 to infinity. Now see, u to the power, it is minus 1, right? So u to the power minus 1 into u 1. Therefore it is only what is it coming? 2 into 0 to infinity e to the power minus u square du. Is it coming or not?
Yes, sir.
Okay. Now what we are doing? I am taking square both side. Gamma half. Now we have gamma half is equal to this integration. Okay. Then I am taking square both side. Therefore, gamma half square is equal to 2 into 0 to infinity e to the power minus u square du into 2 into 0 to infinity e to the power minus u square du. Means it is a product of that integration two times. But what I have done, I have changed the variable for the second. Why? Because in means I can do it, but there are some use that is there are some reason of changing this variable. Can I means do this? It is a definite integral. So in the definite integral, I can change the variable, right? It is also gamma half and it is also gamma half, isn't it? देखो यहाँ पे in that formula of gamma alpha, ये t को अगर कुछ भी लिखते हैं, it is gamma alpha. There is no change in gamma alpha. Okay, t को x, you can write x, t You can write y, you can write z, you can write anything, any other variable. It is like that dummy variables in summation, dummy variable you have seen. Similarly, in definite integral, the variable it is dummy variable. You can change it. So what I did, I have changed u to v for the second integration. Okay. Now here the things came at how I am writing this. It is a product of two definite integral. So if the functions are separated, means two different type of functions are there, we can write them together and we can make a double integration. So how I am writing that you will be informed, you will be let you, means I will tell you after the vector calculus. Okay. So what I am doing, I am multiplying 2 into 2, 4, and I am writing these two integration sides side by side, 0 to infinity, 0 to infinity, and these two I am writing all together e to the power minus. Again, I have written u is equal to x and v is equal to y for my convenience. Okay, but you can keep it in the form of u and v, no issue. If I keep it in the form of u and v, it will be e to the power minus u square plus v square du dv, right? So I can write it e to the power minus x square plus y square dx dy. Now it is a double integration actually. It is called double integration. But this is not. This is not. This form is called a double integration. Now how to solve this double integration? There are several techniques. You can separate the variable and do integration, or you can take some substitution and you do the integration. So here I did substitution. Okay, so two different variables are there in that integration. So I am taking x is equal to r cos theta and y is equal to r sin theta. X is equal to r cos theta, y is equal to r sin theta. Therefore, this will be what? E to the power minus r square, and dx dy that changes to r dr d theta. Okay, don't ask me now how I am writing this. Dx dy is equal to r dr d theta. There is some formula whenever you are changing the variable. It is related to Jacobian. I don't want to mention these terms now. So you just remember dx dy that should be written in the form r dr d theta. Since we are changing x and y in the form of r and theta, so derivatives will be dr d theta and additional r is there. E to the power minus r square, that is by the substitution, and limits. That limits are also important. Here the limits for r will be 0 to infinity and limits for theta will be 0 to pi by 2. Okay. So according to the substitution, we are getting these two limits. Finding limits, it is also an important part of this double integration. So ultimately, it is now an integration in the variable theta and r. 4 into theta 0 to pi by 2 r 0 to infinity e to the power minus r square into r dr d theta. Now you can separate the integration again, means that double integration can be written as a product of two integration, because the integrand here it is a product of r and theta, you can say. So I can write, means I write theta terms with that theta in theta limits, and I write r terms with that r limit. Okay, so 0 to pi by 2, there are no theta term, only d theta. So I am writing 0 to pi by 2 d theta. And for r limit, the terms are e to the power minus r square into r dr. So 0 to infinity e to the power minus r square into r dr. Okay. Now this integration is easy. Theta 0 to pi by 2, so it will be pi by 2. And you solve that integration, you can solve this integration by taking substitution. That is possible, means solving that integration is possible by taking substitution. Okay, so finally after simplification you will get the value is pi. Okay, so what is the pi value? It is equals to gamma half whole square. Therefore what is gamma half? It is root pi. Okay, so you practice this proof 2 or 3 times. Otherwise means you cannot write in the exam, because if in the medicine they give proof gamma half is equal to root pi, then you have to remember this. Okay, in the next class, I will discuss the rest part of these special functions. Then I will go to the Basal function.
Okay, sir.
I take attendance.
So in mathematics in SAP portal it's showing one absent. Sir.
Yes, sir.
I have to see.
Yes, sir.
Yes, sir.